So lack of accuracy of sampling frame. Okay, lack of accuracy of sampling frame. Sampling frame is not accurate. So you have non-random sampling bias, citation bias, disseminations bias, post hoc analysis bias, publication bias. All right. Uneven diagnostic procedures in the target population. Right. So detection bias. All right. Error in detection. Diagnostic suspicion bias, unmasking detection signal bias, mimicry bias itself. I don't know what's this. Okay, let's remove this one. During study implementation, losses of or withdrawals to follow up. Some people just stop from the study, and they stop because of something, non-random withdrawals. Right. Missing information in multivariable analysis. Your model does not have enough covariates. Non-response bias. All right. Okay. Information bias results from either imperfect definitions of study variables, flawed data collection procedures. Okay, so wrongly define variables, wrongly collect data, leads to information bias. This results in misclassifications of exposure or outcome status. So in this type of bias, you will see validity problem, sensitivity problem, specificity problem, reliability problem. Okay, and information bias occur during data collection. In information bias, for example, misclassification bias, you have differential misclassification bias, non-differential misclassification bias, detection bias, observer interviewer bias, recall bias, rumination bias, participant expectation bias, reporting bias, ecological fallacy, especially in aggregated data, secondary data, regression to the mean, Horton effect in clinical trials, lead time bias in screening, protopathic bias, I don't know what's that, temporal ambiguity, Will Rogers phenomenon, work up bias or verification bias. Do you need to memorize all these things? Memorize? I think you don't have to memorize every single bias. You need to memorize the overall groups, the selections, bias, information bias, and confounding, and a few common biases, right? But you need to be able to describe biases that can happen from a study, from a project, from a data collections, from a survey. You don't have to really memorize the name, the specific name of the bias, but you should be able to describe the bias that can happen for a particular project. All right. And lastly, confounding. Confounding most of the time is discussed in a different chapter, right? Not in a chapter of bias. Okay, it is usually described elsewhere, discussed elsewhere on its own chapter, right? But briefly, this occurs when a variable is a risk factor for an effect among non-exposed. Okay, number one. At the same time, it is associated with the exposure of interest in the population. Number two. And number three, it is not affected by the exposure or the disease, right? That's three things that are necessary to define a confounder. Right. Combined selection and information bias, it means that biases that have both selection and information components. For example, medical surveillance, cross-sectional studies, and evaluations of screening. Sparse data bias, small sample size, all right? Small sample size. For example, if you use standardization and you break the table to many small categories, that will produce a sparse bias. Biases in trials, for example, allocations of intervention bias, compliance bias, contamination bias, differential measuring, lack of intention to treat analysis, right? What else? Okay. So, for example, in figure 412, natural history of a study and corresponding bias, from target population to study participants to data collections to results to interpretation to all these different stages have different biases. All right. So you got selection bias here that affect these two stages. Information bias, which affect the data collection. Analytical bias affect the results. Okay, I think it should be analysis. You're right. And even when you have written a manuscript, when you publish, there can also be a publication bias. All right, you tend to publish interesting results, significant results. Okay, right. Confounding, all right, the plausibility bias for your hypothesis. Okay. All right, so next, oops, all right, okay, so let us move this thing. Preventions and control of biases. Okay, prevention and control. So what you can do is to prevent and control bias, ensuring that the study design appropriate, establish and carefully monitor procedures of data collection. Of course, use appropriate analytical procedures. Right. So that is basically the things that we should cover or understand for this chapter or this topic. Lack of validity or biases. The next lecture I will talk about confounding or non-causal association. So I hope you can read the relevant chapters in epidemiology beyond the basics, and I know it is a difficult text. It is very lengthy. What you can do is to focus on the things that I have spoken here, and so limit yourself to the contents that I have described in my lecture, right? So you don't have to read everything inside the epidemiology beyond the basic. It's too much for you, but it is a very good book if you have time and energy and enough motivation. Go and read the chapter.